Alright, so now we're going to go through the definitions for 3D. And these are just general definitions. The first one is After Effects. After Effects is a 2D effects tool. You can do motion graphics in it, you can do compositing in it. It has some limited 3D stuff in there, but typically like you can make animations in here using Illustrator, Photoshop files, or just draw stuff. And you can also bring stuff in from 3D and composite it with those 2D things or use it by itself. Ambient Occlusion, this is a render pass. So I'm going to read in a file here. Alright, so this is a 3D rendering. And I'm going to look at the ambient occlusion. And essentially what this is a black and white pass that shows where everything is making contact. So where the knob here is making contact with this, where there's a little bit of a gap, it basically makes a black line. And the purpose of it is that you would use this on top of the original render in order to make a little bit more contrast inside of it. So just so we can see how that would work. Multiply this and set that to that. Okay, so now if you look at the button here, as I hit the disable key, you can see the before and after. So it just brings up a little bit more contrast in those areas, making your shadows a little bit deeper and your lines a little bit crisper. So typically that's something you want to have on your stuff if you're trying to make it look realistic. Anti-Aliasing is a filtering process that makes our rendering look nice and smooth. So if I go into this scene here, I'm going to turn down my anti-aliasing to lower ridiculous settings. And then you can see it looks pretty horrible. It's all grainy around the edges. And then as I take this anti-aliasing up, now it's smoothing out. And eventually what will happen is the edges here without anti-aliasing are very blocky, like that. And then what this does is just kind of goes in and refines. And all 3D softwares have this, it's just a matter of where it is. And Maya is just like this one slider here. Axis is the direction that something will move in. So for this item here, its axis is right there. It's like its pivot point. I can move this around, so if I needed to move this into whatever direction or rotate it, I could do that too, and then it'll change how my character is able to move inside the scene. Backface culling allows you to see or select items behind you. So if I have this item here, and I go into wireframe mode, I can see all the lines behind it, and I may not want to see those lines. So if I go into backface culling, it hides the lines behind me, behind the object, so I can't see what those are. This is typically a good thing to have when you're doing some advanced models where you have a lot of stuff going on. Most of the time you don't need to turn it off, but again, it's something good to have on there. Box modeling is a technique that uses basic shapes to create your end object. So this creature here was started off as a blocked model, started off as a cube. And just by adding divisions and pushing and pulling and tweaking, I was able to create this shape. His end product is to have this many divisions. There's no way that I would want to model this right with this many divisions. I'd want to start off with something small and build to that shape. Okay, so that's what box modeling typically entails. I'm going to talk about two things here. So one is bump map, and then the other one is displacement. So bump mapping allows us to take a picture or a material or a texture, and it allows us to apply it to an item. So this one here has bump mapping, and this one has displacement mapping. And I'm going to render this. And what the picture is just a checkerboard. So on this item here, the bump map makes it look like it has bumps in it, okay? But it doesn't actually physically change the surface of that item. A displacement map, on the other hand, does change it. So this and this are the same exact item, but this one has a checkerboard displacement, this one has a checkerboard bump. Sometimes a bump map is what you want. Sometimes a displacement map is what you want. It all depends on what your end goal is and how close you're going to get to your character. Cinema 4D, and I'll also talk about Maya as well. These are just two of the many 3D tools that are available. This is Maya. The interfaces for any 3D software are very similar. There's not like a huge, incredible difference between them. What they can do is different. The capabilities, how you do things are different. But essentially, anyone trained in any of these tools can do that, can utilize it. This is Cinema 4D. You'll see it's very similar looking. We have our 3D interface. We have selections and materials and tools and all that stuff. As long as you know one of them, typically the stuff will translate to other softwares as well. We'll talk about Cmyk and RGB at the same time. Well, that's way over there. If you're in Photoshop, go there, and you have a picture of something, typically if you take it with your phone, you have these channels which are red, green, blue. Okay, and that's what makes up that image. Typically if you're going to be printing something, you're working in Cmyk, sure. And that's going to deal with cyan, magenta, yellow, and black. And this Cmyk is typically something, if you're going to print it, you'll print with Cmyk. If you're going to use it on the screen, you'll use it for RGB. Okay. Direct illumination, and then I'll also touch on global illumination, and I'll also touch on indirect illumination. Okay. So direct illumination is, let me make sure this is on. Let me turn off these features here, turn that off. Turn that on, there we go. And that should be good, okay. So I'm gonna render this picture again. So what we have here is direct illumination. The light here is shining on these items, and it's illuminating it. If I go to the other side, we'll see it's in complete darkness, okay? So the only thing that's actually lighting up these surfaces is that light shining on top of them. Now we know from the real world that that's not how things work. Typically in the real world, we would have this thing called bounced light, okay, which is indirect illumination. The light hits the surface, bounces, and then hits that, so it's indirect. And so now you can see this is indirectly being illuminated by the bounced light hitting this, okay? Now, so direct illumination is the main light shining down, hitting this. Indirect illumination is the light that gets bounced off and shines back. And the whole process of that calculating is called global illumination. How all these things get calculated is that. Okay, so you have direct illumination, which is the light coming off of it. Global illumination is a method of the light bouncing and emitting from objects. And then you have indirect, which is the light which is bounced off of a surface. Okay, so those work hand in hand. Edge loops, as you're doing box modeling or any kind of modeling, typically we worry about making sure that everything flows nicely. So when I go in here and grab one of these edges, it should loop all the way around. Same thing here, same thing there, same thing there. These are all edge loops, and as I model stuff, I typically want that to be a thing so that it's easier for me to model things, move things, scale things, add new edge loops, all that. You'll also notice, and this is another one of our definitions, that we have four-sided squares everywhere, so these are called quads. Every one of my faces, this is a face, these are the edges. Every one of these faces has four edges attached to them, and those are called quads. Typically that's how you want to model things, is in a quadded mode. Something like this has these triangles up here, and those triangles typically don't render nicely. If you have enough divisions and your object isn't deforming, yes, it's fine, you can have triangles. But for a character like this, if I were to have a triangle in the center of his chest or something, you would definitely see that as he's moving. You would see this like pinching or poking that happens there. And then while we're also talking about faces and edges, we also have vertices. And vertices are just the points that are right here. Okay, and Cinema has these as well. So in cinema, you have points that are there, you have edges, and then you have faces. Okay. Extruding is a tool that allows us to add new faces to things. So if, let's say, this guy has a second head or neck, I can grab some faces. I can go to my extrude tool, and then I can just pull these out. And then I can extrude again and pull that out. Okay. Now, it takes more time to tweak it to get it to look like a head, but that's essentially the gist of it. I just start extruding stuff. And that's how a lot of this was created, by extruding, and then using some of my other tools as well. Fall off is a softening of the edges of a tool or item. If I go in here and I want to grab, let's say, his head and move it. So I'm going to grab just his head like this. Make sure I have all these. Yes, okay. So I have all the faces here and I move it. You'll see a very abrupt change in how it's moving around. If I turn on my soft select, this has a softening that happens here, a fall off that happens there on the edges. So instead of it being an abrupt change, it'll softly adjust where those edges are. And I can change what that is by adjusting the soft select tools to control how this is moved around. Okay. Now that's not just for this tool. That fall off is on lots of different things. If I created a light and I look inside here, you'll see that there is a decay rate, which is a fall off for the light. It's the drop off of the light. Okay. Fresnel is the way that reflections and light bounce off of surfaces. Where is this? All right, so this is the Fresnel index of refractions, okay, and these kind of go hand in hand. Fresnel refers to, okay, the reflections in this one are mostly on the outside, not much in the middle. And as you get closer to this higher number, the reflections are pretty evenly around the edges and in the center. Okay, so the higher that index of refraction, the more your reflections are all over the place, and the lower, you'll get more of that reflections kind of around the edges, more natural look, like this. And this whole phenomenon is called Fresnel, okay, how the reflections are bounced around. So you'll see Fresnel is here, and then right here is index of refraction, okay, and that's just the amount that's happening. This is also used in reference to glass, so the amount of glass that is bent around an item when the light goes through it. We talked about that. High dynamic range images. So when we talk about lighting, we're always trying to emulate real-world lighting. So I'm just going to turn this off. Actually, let me turn it on for a second so we can see. I'm going to render this scene out. And you'll see that it's very static light. It's just a white light coming in from this side. But we know that in the real world, light typically doesn't come from just one side. There's usually an environment or something that's also kind of bouncing light around. So inside of my 3D app, I have this sphere that has a picture on it, and that picture is going to be an HDR that basically lights up my scene. And this is going to give me more realistic lighting. Instead of my character just being in a one light scene, now he has this entire environment that's helping light him up, and it's looking much more natural than it did a minute ago. Okay, and those HDRs are things that you can download from the internet and utilize. Typically, you want them to be, this is not stopping, there we go. Typically, you want them to be higher resolution, so you get lots of detail in them. But yes, there's plenty of resources out there for getting that. This next one, hue, saturation, and value. This just refers to the way that we are selecting colors. Oh, Maya is like locked up. All right, so my computer just froze up for a minute, but it's fine now. Hue, saturation, value is just the method of selecting colors. So typically when I select colors for an item, come on, grab the right item. Okay, let's grab something, there we go. Typically in 3D you have HSV, but this could also be changed to RGB if you're more comfortable with that. Typically HSV is like the best thing in the world. Hue, saturation, and value, and it's a lot easier to select a color when you use HSV. An Ies light is just a different kind of light. So this is a sky dome light, is what that is. An Ies light is this little dot, and it basically allows you to light up objects using what are called light profiles. Light manufacturers have light profiles, which basically show like this is what a light would look like, and instead of it being just a flat, boring, solid color, you have these differences inside there where the light is intense in some areas and not in others. You'll see a lot of these used when you do interiors. You want your lights to look as natural as possible, and this is how you do it. Index of refraction we talked about, indirect lighting we talked about. Interpolation is just referring to how we get from one item to another. So this could mean points, keyframes, edges, or other items. Right now this is being interpolated as very blocky, but if I hit 3, now it's being interpolated as smooth. If I have keyframes and I have blocky keyframes, I can smooth those out, okay? So interpolation just refers to that setup there. And a keyframe is used to specify a point in time. So if my Chykster guy is going to be animated here, and then he comes up to this point and goes there, now I've set some keyframes so that he actually would move forward. Okay. Keyshot is a software that provides real-time rendering. So this is what Keyshot is. Cancel that. And basically, as I'm moving around in the scene, I can pick like an angle here, and it's just going to render it right there and figure out what it's supposed to look like. If I want to change any of the colors, I can just drag a new color on there, and now I have a new color, and then it updates what it looks like. A lot of objects are modeled in a 3D software like Maya or Cinema, and then brought into Keyshot to do a final rendering. Lathe or Revolve is just a technique to take a curve and create a surface off of it. So here's my curve. I'm going to go to my Surfaces menu and go to Revolve. And that just makes a surface out of that curve. So it's kind of like taking an Illustrator curve and creating a surface based off of that. Okay. Layers in 3D, we just use these for organization. That's the main takeaway with that. We have layers organizing things, but they aren't used for a stacking order. Mari is a tool that allows us to paint on our models. So here's that same Chykster guy. So instead of me putting a picture on here, I can actually go ahead and paint exactly what color I want my character to be. Let's take a minute. Okay. And then I can also paint actual textures in here, like pictures. I could bring in a picture of animal scales or something and use that. Think of Photoshop, but with 3D items. Okay, so that's what Mari is used for. Mesh is just another name for a polygon object. So as I'm modeling these things here, I can refer those as a polygon or a mesh. It's interchangeable, really. Mudbox or Zbrush is a software that allows you to sculpt a surface. So this is a Zbrush sculpt, and it allows you to go into very high detail resolution. If I zoom in here, you can really see the pores that are on top of Dobby's face. And it's more of like a sculpting tool versus a modeling tool, because you're like more sculpting like clay versus, you know, pushing and pulling and extruding. It's just kind of like pulling clay, pushing clay, that kind of thing. A node is just a generic container that can hold different kinds of information. In Nuke here, every one of these things is a node, okay? And Maya uses nodes, Cinema now uses nodes more than it used to. But basically it's just a way to kind of connect things and how one item will flow from one area to another area. The more deeper you get into 3D, the more you'll kind of play with these kind of node setups here. Nonlinear animation is not what I did with the Chykster, okay? Or what I did with the Chykster. I set a keyframe here at 1, and then I jumped over to 50 and set another keyframe. That's nonlinear. I could also go in here to 20 and then do something else and then set another key. So I can kind of bounce around to the different keyframes to get them to do different things. If this was linear, I would basically have to go to, let's say, 50 and set a key, go to 51, move them a little bit forward, set a key, go to 52, move them a little bit forward, set a key, go to 53, move them forward, set a key. So you can see how this way could take a long time, but this is typically what people are doing. More of the old-time animators will use this kind of setup for their stuff. A normal is just a line that comes out the face of an object. So here is a polygon, and if I go to my face normals, you'll see these little green things poking out. This is basically showing you what is the outside of the face. If I'm inside here, that's the inside of it. You can see I don't see the thing sticking out. There's a little bit of a nub, but nothing crazy. Okay. Same thing there, same thing there. So the normal is typically used to show you like what is the outside of that face. Nuke is a software we use to composite 3D and 2D elements together. It's a little bit more in depth than After Effects in that I have 3D here, but or 2D, but I also have a 3D environment. And if you do any high-res stuff, you can really do a whole lot with this system setup. This is a single node with this multiply on here just to show that ambient occlusion, but the file I'm opening in a second, whenever it feels like it. Try it again. It'll open up several copies. All right, here is that other one. So you see lots of nodes here, lots of things connecting. So I'm basically taking this one rendering. It has all of these different passes in it, different ways that I can visualize what this thing looks like. Oops, that's the wrong one. There we go. Okay, I'm using all these render passes and then splitting it apart. Oops. And then changing what it looks like. So if I go to my end result here, that's what it looks like at the end, and this is what it looks like at the beginning. So you can see there's a bit of a difference in how I've set that up. I've added a glow to the screen, changed the button colors. You can do a whole lot with Nuke. It's an amazing program. A null is just an empty object that allows us to store data. So if I'm in Cinema and I just hit Alt-G, come on. Oh, I had to click something, that's why. Alt-G, it'll create a null that allows me to save information or group items together. So it's just an empty item that you can store stuff inside. A pass or a render pass is what I was doing inside Nuke. All of these things that I rendered out are different passes, different ways to basically break apart what the surface looks like. One of them is a depth pass. If I can find it. There it is. And this basically saves the information of where that item is in 3D space. You can't see it right now, but as I drag this to the left and I drag this to the left, nope, still nothing. That's to the left. It's in there somewhere. There it is. We can vaguely see this thing kind of getting made out. There it is. Okay, so this is actually like how far from the camera each one of these pixels is on this item. And I can use that to actually create a depth of field mask, or a depth of field on it like you would in a regular camera. Okay, so there's a bunch of different render passes. The idea is that you're able to isolate certain elements to do that. Photoshop's a program, you should know that, for texture painting, manipulating, enhancing images. Physical rendering goes in with global illumination and indirect lighting. It's basically we're just trying to create as realistic of an environment as possible with the bounced light, with all of that. They call it different things. In Cinema, they call it physical lighting. In Maya, they call it something else. Okay. The quad we talked about. Rendering is just taking all of our 3D items, lights, materials, and then just calculating what do they actually look like in the, once they're all calculated and done. Sampling is how we refine our elements. So as I was inside of Maya and I was playing around with my anti-aliasing, these are all just anti-aliasing samples. These are diffuse samples. So the more samples you have, typically the longer it's going to take, but the more realistic it could look. Snapping is just a way to snap things together so that if I have this item here and I want to move it to a specific spot, I can snap it and basically lock it to certain items. Maya has, all the softwares have them, but Maya has like point snapping, curve snapping, and grid snapping, and Cinema has a lot more different ways to snap, but they don't have hotkeys for it. All of Cinema's are down here in the snapping area. Subsurface scattering is a way that light bounces inside of a surface. If you've ever seen like your hand in front of a light, that's just subsurface scattering. Without it, there's no light kind of coming through. With it, you can see the light kind of coming into the skin and bouncing around. Same thing with the candle here, gummy bears, and this lemon slice. Okay, so an important thing when you're trying to emulate real-world surfaces is understanding all of these real-world techniques. Texture maps are just images to get something to look like you want. So if you wanted a floor to look like wood, you find a picture of wood and bring that in. Okay. Topology refers to just how your surface is laid out. When we go in here, you can see the topology, all the lines and how they flow around here. That's good topology. If I went to Dobby here and I looked at his, okay, this is really messy topology because there's literally millions of divisions all over the place. Okay, and it doesn't really flow very nicely, and it'd be a pain to have to like work with outside of this tool, but inside the tool it works pretty good. Okay, triangle we talked about. It's the thing on the top of that. We don't want triangles, we want quads. Unreal is a gaming engine. So if we have our 3D items, one of the pathways for it is we could actually model like this building here and drop it inside of a gaming engine and have a character walk around or interact with our 3D environment. They could open doors, they could have the building explode. There's a lot of different things you can do. More and more of these things are coming into usage because of the speed of computers and mobile devices. Vertices we talked about, and then Z depth we also talked about, which was that depth pass right here. Okay, so that's the definitions for 3D, and hopefully you learned a little bit.